Hi everyone, I'm Lucas Rezende Santos from Cefet Rio de Janeiro, Campus Angra dos Reis. I'd like to take this opportunity to talk about the use of coconut shell produced in the Brazilian Green Coast for small-scale electricity generation. In this study, it is proposed to analyze the incorporation of a cogeneration system with an internal combustion engine, aiming at implementation in the city of Angra dos Reis. Before I start, I'd like to show the presentation agenda. First, I'm going to introduce the Brazilian scenario about the use of coconut shell as a biofuel. After this, I'll show you the materials and methods used in this study. In the next session, the results obtained, the conclusions of this study, and at the end, my acknowledgements. So, in the current Brazilian scenario, the use of advanced biomass energy shows as an imminent potential. However, it is still a source of energy dispersed in the country. The green coconut shell is a very abundant element in Brazil, but according to Carrijo et al. 2002, 125 coconuts after being consumed occupy a volume of about 1 cubic meter in landfills. PASS 2005 estimates that 1.1 to 3.4% of all urban solid waste in the state of Rio de Janeiro is composed of coconut shells, which is a considerable value. In the region of Angra dos Reis, according to PERS 2013, the production of green coconut is 0.81 kilograms per inhabitant per day, and considering its population, which according to IBGE 2019 is about 200,407 inhabitants. With all this data just showed, it's possible to estimate a production of green coconut shell of approximately 1,786 kilograms per day in the region of Angra dos Reis. Therefore, it's visible that there is a problem with the dumping of green coconut shell in the state of Rio de Janeiro, whose solution may be its use in power generation. So, based on all these facts, it's proposed a thermal plant for biomass gasification. This plant has four main control volumes. Here's the plant, and here they are. First, a rotary dryer, who emits the moist green coconut shell and processes it to reduce its humidity. Then, we have a bubbling fluidized bed gasifier, who emits air in the green coconut dry, taking the gasification process who results in listing gas. The latter has some impurities that will further be removed by cyclone. Continuing, there is a 4-strokes and Otto cycle internal combustion engine, who emits the poor air-fuel mixture and converts around 107 kilowatts into electricity. Part of the resulting dissipated energy will be used with heat exchangers. And here they are. And we got two. First, Calvin current type, also known as jacket heat exchanger, which is used for cooling the engine. The second one, the Hill and tube, to heat water using heat from the exhaust gases until saturated steam is obtained in order to be used in the drying process. Hence, to develop the thermal plant show, it was performed a technical analysis. And first, a thermodynamic analysis was performed according to the first law of thermodynamics, stated below, on the four control volumes aforementioned, such that it was possible to obtain the electrical power efficiency supplied by the engine by the equation presented below. Then, it was obtained the thermal efficiency of the heat recovery cycle by the equation below. In order to verify the economic viability of the project, an economic analysis according to Xavier 2016 was performed. First, it was calculated the cost of producing the fuel, just as the equation shown below. Then it was calculated the energy losses. After, the cost of heating water was calculated. And at the end, it was calculated the cost of rating dry biomass. About the results, in the technical analysis, it was necessary to dimension the most suitable engine for the thermal plant, and the proposed working conditions on it are considered to be 8 hours per day for 330 days, such that the remaining 35 days will be used for failures and necessary maintenance. In this way, the syngas parameters were all about a total of 223.2 kilograms per hour of available wet biomass, 156.24 kilograms per hour of biomass inserted in the gas fire, and a total of 239 Newton cubic meter per hour of syngas introduced in the internal combustion engine. Based on the aforementioned premises, it was decided to use an internal combustion engine with a mass fuel flow of 0.074 kilograms per second. Thus, through a Caterpillar catalog of internal combustion engines, the model G3516LE was chosen. The performance of the internal combustion engine model G3516 in the cogeneration plant for the production of electricity and heating both biomass and water was obtained. The electricity energy produced was 107.51 kilowatts. The electrical power efficiency 30.39%. The temperature of exhaust gases was 439.4 Celsius degrees. The fuel mass flow was 0.074 kilograms per second, and the exhaust gases mass flow was 0.264 kilograms per second. Then, the energy distribution of the proposed plant with the G3516 engine was obtained. In this graph, there are the thermal efficiency, which is about 26.1%, the electrical efficiency, which was about 30.39%, just as shown before, and the general losses, which are about 43.51%. About the economic analysis, the production costs with interest taxes of 2, 4, and 12% were obtained. First, we got the fuel costs in reais per kilowatt, with all these three taxes. Then, we got the cost of hot water and steam production, also in reais per kilowatt, with all these three taxes too. Then, we got the dry biomass cost, also in reais per kilowatt, and considering the three taxes. And at the end, the cost of electricity production, also in reais per kilowatt, considering these three taxes again. Now let's go for the conclusions. The first one is that the use of green coconut shell is presented as one of the most effective ways of obtaining energy, due, in addition to its good efficiency, the important socioeconomic bias that the use of this material in gasification plants can bring, which is reinforced by the fact that there is an extremely promising future for the use of biomass in the national and global energy matrix. The second conclusion. The city of Angra dos Reis will need an intense collection of the coconut shell, and this happens in order to enable the operation of the thermal plant. The third conclusion. The engine chosen produces only 10% of its original power, using the syngas. Due to the great difference in energy supplied between natural gas or biogas, which was 47.3 megajoules per kilogram, and the syngas, which was about 4.7 megajoules per kilogram. But even with this fact, the engine is still working with high efficiencies. And the fourth conclusion: system losses were minimized by 26.1% due to the implementation of heat exchangers, and they made it possible a direct portion of the energy to the biomass drying process. Therefore, this study allowed an immersion in the thermochemical conversion of biomass, showing the feasibility of reusing agricultural or industrial waste for the generation or cogeneration of renewable energy through small technological implementations that already exist. At the end, I would like to thank the Cefaterio CNPq program for the opportunity given, and the coordination of Encit 2020 for organizing this event. Thank you.